Hello friends, I welcome you in lecture number 16 on complex integration. In previous lecture we have discussed what is Cauchy Goursat theorem, and now we know that if we have a simple closed contour and suppose our function f of z is analytic at all points inside and on this simple closed contour, then integral along that simple closed contour is always 0. So in this lecture also we are going to discuss two more examples on Cauchy Goursat theorem. Here our function is 1 divided by z square plus 2z plus 2, and we have to evaluate this integral along the contour C, which is unit circle, that is circle with center 0 and radius 1 in either direction, that is either in anticlockwise or in clockwise direction. So first we write down what is given function. F of z is 1 divided by z square plus 2z plus 2, and first we have to determine the points at which this function is not analytic, and then we will check whether those points are inside this circle or outside this circle. Now we know that this function is division of two analytic functions. One is constant function, it is analytic everywhere, and z square plus 2z plus 2 is polynomial function in z, and that is also analytic everywhere. Therefore this function is analytic everywhere except at those points where this z square plus 2z plus 2 becomes 0. So first we determine the points for which z square plus 2z plus 2 becomes 0. So for that we solve this equation. Now this I can rewrite as z square plus 2z, and I rewrite this constant 2 as 1 plus 1, and that is equal to 0. And therefore this we can observe that this is square of z plus 1, that is z square plus 2z plus 1, and I transfer this one on right hand side, therefore I will have minus 1, and we know that minus 1 can be replaced by square of imaginary number I, so I write minus 1 equal to I square, and from this if I take square root on both sides, I will have z plus 1 equal to plus or minus I, square root of I square, and therefore z is minus 1 plus or minus I, or we can have minus 1 plus I comma minus 1 minus I. So denominator z square plus 2z plus 2 becomes 0 at z equal to minus 1 plus I and z equal to minus 1 minus I. This is 0 when z is minus 1 plus I and minus 1 minus I. That means this function is analytic everywhere except these 2 points, z equal to minus 1 plus I and z equal to minus 1 minus I. So we can write that therefore f of z is analytic everywhere except z equal to minus 1 plus I and z equal to minus 1 minus I. Now I have to check whether these 2 points are inside this unit circle or outside this unit circle, so that we can easily check. Our contour is unit circle, contour C is mod z equal to 1, so I can find out absolute value of this and this. If they are greater than 1, then they are outside this contour. So first I find out absolute value of minus 1 plus I, and that is nothing but square of minus 1, that is real part square, plus square of imaginary part, that is coefficient of I is 1, and this is going to be square root of 2, which is greater than 1. Therefore we can say that minus 1 plus I lies outside this contour C. Similarly, if we find out absolute value of minus 1 minus I, then here real part is minus 1, imaginary part is also minus 1. So this is also going to be square root of 2, and therefore we can write that minus 1 minus I lies outside the contour mod z equal to 1. And if you wish, you can visualize using figure also. Suppose we roughly try to sketch all these points, and our contour is mod z equal to 1. So suppose this is contour mod z equal to 1, radius is 1, so we will have somewhere here 1, this is I, and this is minus I, here I have minus 1, circle has center 0, and our points are minus 1 plus I and minus 1 minus I. So minus 1 plus I, that we can rewrite as minus 1 comma 1, and that is somewhere here. Here I have minus 1 and here I have 1, so this point is minus 1 plus I. Okay, we can write this I as ordered pair 0 1, and this is minus 1 comma 0, and minus 1 minus I is somewhere here. This is minus 1 minus I. So at these points function is not analytic, but they are outside this contour mod z equal to 1. So we can visualize by drawing figure also, or we can check in this way. We put z equal to minus 1 plus I and z equal to minus 1 minus I in mod z, and we check what is the modulus. If modulus is greater than 1, they are outside the circle. This means function is analytic at every point inside this mod z equal to 1 as well as on mod z equal to 1. So what we have observed is that this function f of z is analytic at all points which are inside and on the boundary of the contour mod z equal to 1, and this is simple closed contour. Our contour must be simple as well as closed to apply Cauchy Goursat theorem. So that also we have to take care, and therefore by Cauchy Goursat theorem integral is 0. Integral of function f of z along given contour is 0. And what is f of z? We have taken f of z as z square plus 2z plus 2. This is equal to 0 along given contour, which is unit circle. And because this is 0, it does not matter whether we are considering counterclockwise or clockwise direction. If it is 0 along counterclockwise direction, then it is 0 along clockwise direction also. So sometimes they can ask you to find out or evaluate this type of integrals. So you can check whether your contour is simple and closed. Then you can check the points at which given function is not analytic. So if those points where function is not analytic are not inside as well as on the boundary of given contour, then integral is 0 by Cauchy Goursat theorem. I have taken another example in which our function is sec z. So first we have to determine the points where sec z is not analytic, and here contour is unit circle, and unit circle means circle with center 0 and radius 1, and that is simple and closed contour. Therefore we can think about application of Cauchy Goursat theorem. Now sec z is nothing but 1 divided by cos z. Therefore sec z is not analytic at all those points where cos z becomes 0. We know that this 1 is analytic everywhere, being a constant function. Cos z is also analytic everywhere. and therefore this division is analytic at all those points where cos z is non-zero. So first we write down the points where cos z is 0. So we know that cos z is 0 if we have odd multiples of pi by 2, that is plus or minus pi by 2, then plus or minus 3 pi by 2. Similarly we can have plus or minus 5 pi by 2 and so on. Or we can write that if z is 2n plus 1 times pi by 2, where n is any integer. For n equal to 0 we will have pi by 2, for n equal to minus 1 we will have minus pi by 2, for n equal to 1 we will have 3 pi by 2 and so on. So all these points are those points where sec z fails to be analytic. Now what about location of all these points, whether they are outside the unit circle or not? Unit circle means circle with center 0 and radius 1. So approximately suppose this is circle with center 0 and radius 1, then this is 1, here we have 0, this is I or order pair 0 1, this is minus I, this is minus 1. Now pi by 2 is roughly 3 point something, so if this is 1, this is 2, and somewhere here we will have this pi by 2. Similarly minus pi by 2 will be somewhere on this side, minus 2 minus 3 somewhere here, and then 3 pi by 2 will be further away from this point, and minus 3 pi by 2. So you can see all these points have imaginary part 0, that is y equal to 0, therefore they are on x axis. If we have positive sign, they are on positive x axis. If we have negative sign, they are on negative x axis. But all these points, if we take absolute value of mod z, that is 2n plus 1 pi by 2, then this is always going to be greater than 1. That means the points at which sec z is not analytic are all outside this unit circle mod z equal to 1, and this means sec z is analytic at all points inside this simple closed contour as well as on this simple closed contour, and therefore integral is 0 by Cauchy-Goursat theorem. So we can write that sec z is analytic everywhere except z equal to 2n plus 1 pi by 2, n belongs to z, but these points are outside the contour mod z equal to 1. Therefore sec z is analytic everywhere. Sec z is analytic everywhere inside and on this simple closed contour mod z equal to 1, and we mention that which is a simple closed contour. It is necessary that our contour is simple and closed, and our function is analytic everywhere inside and on a simple closed contour to apply Cauchy-Goursat theorem. Therefore by Cauchy-Goursat theorem, this integral of sec z along unit circle is 0. So you can see it is very easy to prove that this integral is 0, and but we have to mention all these things. First we have to write down that at which points sec z is not analytic, and then we have to check whether all those points are inside or outside or on the boundary of the given simple closed contour, and we have to write all these things in this way systematically. We just don't have to write down that integral is 0 by Cauchy-Goursat theorem. They can ask you this type of questions for minimum 3 marks, so you have to write all these things systematically. So I think we have done enough problems on Cauchy-Goursat theorem, and from next lecture onwards we will focus on another result which is known as Cauchy integral formula. So I stop here. Thanks for watching.